Good morning, or I should say good afternoon for some. As you can see, I have your Chapter 8 mid-chapter review shown here, and I'm going to take the time to go over some of the problems according to the data that I saw on All in Learning. You did pretty good, but I just want to make sure that you truly understand some of the questions and how to solve them, because again, I'm not with you all as you take this, or will not be with you all as you take the actual test. But however, I am going to put Go Guardian on as you take the test, and you will be kicked out if you go outside of All in Learning. Anyway, I only have 15 minutes to go over this review because this particular app that I'm using only allows me 15 minutes. So I just want to go over a couple of things with you in regards to when we started Chapter 8, dealing with equations and inequalities, but we're just focusing on equations today. You learned about 4 different properties, and the properties are the addition property of equality, the subtraction property of equality, the multiplication and division property of equality. And those properties basically state that if you have a subtraction problem, or I should say a subtraction equation, then you would apply the addition property of equality to solve it. Basically saying if you're solving a subtraction problem, if you're solving a subtraction equation problem, you will add on one side of your equation and then add on the other side of the equation the same exact number. So basically, whatever you do to one side, you must do the same thing to the other side of your equation. So again, if you had a addition equation, then you would use the subtraction property of equality to solve. And the same thing for multiplication. If you had a multiplication equation, you will use the division property of equality. And with that being said, for question number 1, it says which property of equality is used to solve this equation, which is a negative 15 and 75/100 equals to 2 and 5/10 x. You will use the division property of equality. So the correct answer is D for number 1. Number 2, it says which statement explains how to solve 4/9x equals a negative 81/100. Now, you can automatically, using process of elimination, just get rid of answer choice A and answer choice B, because this is a multiplication equation, and I just reviewed that if it's a multiplication equation, you're going to do the inverse operation. So if you're looking for division to be used with this particular problem, you won't see that operation written here. And the reason being because this is a not a coefficient, excuse me, this is dealing with rational numbers in the form of a fraction, and you have to apply your knowledge with dividing fractions. And remember, when you're dividing fractions, that you take the divisor of the fraction part of it and find the reciprocal. In other words, not find the reciprocal, but you will multiply both sides of your equation by the reciprocal of 4/9, which is 9/4. I know I probably made it sound more confusing than it is, but again, this is a division problem, a multiplication problem, but you're going to divide both sides by the reciprocal of the coefficient of x. So the correct answer choice for number 2 is going to be D as in dog. Multiply both sides of the equation by 9/4. Number 3 is also a multiplication equation, and you will divide both sides by the coefficient of D, but you're really multiplying both sides by the reciprocal of the coefficient of D. So you will divide both sides by a negative 3/2, and your correct answer for number 3 is C. It is C. Number 4, number 4 is similar to number 3. It's just that the rational number is in the form of a decimal, and you will divide both sides by the coefficient of B. And when you do that, your correct answer for number 4 is D as in dog. Now, moving to question number 5. Some of you, I would say about 25% of my students out of the number of students I teach, you all missed this problem. And this is nothing but, it's a multi-step equation, but once you apply the distributive property, you end up with a regular two-step equation. So as far as the distributive property is concerned, you would distribute a -2 with x, then a -2 with 12, and you end up with a -2x plus a -24 equals 4. So once you distribute a -2 with x and 12, your two-step equation ends up being a -2x plus a -24 equals 4. Now, this is addition and multiplication. So the first thing we want to do is get a -2x by itself. In order for us to get a -2x by itself, you have to get rid of a -24. And the way you do that is by adding. You're going to add 24 to both sides of your equation, and the equality property that I'm using is the addition property of equality. So once you cancel out a -24, you will then have a -2x equals a +28. A +28. So now you have a multiplication equation, and you're going to do, or I should say, divide both sides by the coefficient of x, which is a -2. And when you do that, you get x equals a -14. So your answer choice for number 5 is going to be B as in boy. All right, moving on. We have about, or you will have about 4 equations, or I should say word problems on your test. This next section deals with some word problems. It says solve each problem by writing and solving an equation. So when you look at 6 and 7, I told you 3 things to kind of figure out as you try to work through the problem. And the 3 things I told you after you read through the problem is write down what you know, then write down what you need, and then plan out how you're going to write out your equation. So the first thing we want to do is read through the problem. Together, Sarah and Juan ate 26 crackers. If Juan ate 4 more than Sarah, how many crackers did Sarah eat? So what do we know? We know that Juan and Sarah both ate 26 crackers. So we're going to just jot down 26. And then it stated that Juan ate 4 more than Sarah. So I'm just going to put 4 for what I know. He ate 4 more than Sarah. Now, let's talk about some of the key words that are in this particular word problem. More than. More than is a phrase that you learned back in chapter 7 dealing with expressions. More than represents addition. It represents addition, so that means we're going to have an addition problem with multiplication. An addition problem with multiplication. So, how many crackers did they eat? They ate 26. So 26 is the actual answer to your equation. But we have to figure out how many crackers did Sarah eat. Well, 4 is going to represent what or how many Juan ate. So we know 4 is going to be part of the equation. So right now we know 4 is representing how many crackers Juan ate, and 26 is representing how many crackers Sarah and Juan ate. So now we got to figure out what goes next in our equation. So we know we're adding, so we know answer choice C is not going to be the answer. And we know that for answer choice D, we're not trying to figure out how many Juan Juan ate more than Sarah. We're trying to figure out how many more did Sarah eat than Juan. So the only or the best solution or equation that goes with this word problem is answer choice A, because 26 is representing how much they ate. The 2 is representing the both of them, which is going to tell how much more Sarah ate than Juan. And when you solve the equation, the solution for y is going to be 11. So the answer choice for number 6 is A. All right, and then I got to hurry up. I'm about to run out my time in a little bit. Julian's pool currently has 12 inches of water in it. He can pump 8 inches of water into the pool every hour. And how many hours will the pool have 60 inches of water? So what do we know? We know that he pumped 12 inches of water into the pool. It says he can pump 8 inches of water into the pool every hour. So how many hours will it take for the pool to have 60 inches? So 60 inches is our answer to the equation, but we need to know how many hours it's going to take. So we're going to use x for a variable, and we know that 12 inches is already in there, but we know that if we pump 8 inches, how many hours is that going to take? So we know 12 is going to be part of one side of your equation as well as 8. So are we adding here or subtracting here? Well, if we are trying to figure out how many inches is going to be added in the pool to equal 60, we're adding versus subtraction. We're not taking away from anything. So go ahead and eliminate answer choice A. Answer choice A will not be a part of the solution or the answer. So when we look at letter C, well, X can't stand alone because we already know that you can get 8 inches per hour. We just don't know how many hours it would take. So we can eliminate C. So now we got to work with answer choice B as in boy and D as in dog. Even though B and D are the correct equations for this particular word problem, however, D is not solved correctly. They're missing a step for D. So the correct answer choice for number 7 is B as in boy. B as in boy. 8x plus 12 equals 60. And x is equal to 6. That's how many hours it would take to get 60 inches of water in the pool. All right, so moving forward, it says translate each sentence into an equation, then find each number. The sum of 6 and a number divided by 2 is equal to 0. The sum of 6. The sum of 6. Well, the key word here, sum, lets me know it's going to be addition, and divided by is going to be, lets me know it's going to be division. So the correct answer choice for D, for number 8, is D. Y divided by 2 plus 6 equals 0. And the equation is solved correctly. Your answer would be y is equal to a negative 12. Y is equal to a negative 12. If some of you are wondering why you couldn't start out with 6 plus y divided by 2, because you can change the order of addition. Well, the answer choice A wouldn't be correct because you should have y as a negative versus y being a positive. But you can change the order of addition and your answer still will come out right. Okay, moving forward to number 9. I'm running out of time. Number 9 is B as in boy. Number 10 is C. Number 11 is B. Number 12 is B as in boy. Number 13 is B. 14 is B. 15 is C. So again, if you didn't understand me for 11 and 12, 11 is B as in boy. 12 is B as in boy as well.